Students, am I audible to you, all of you? Am I audible, guys? All right. So let us start. So first of all, students, all of you must have noticed that I have uploaded the PPT, right, on both the groups. If you are part of both science and environment, then on both the groups I have uploaded the class PPTs. But let me give you a disclaimer here that when I upload the class PPT, I basically upload the one which we have used in the class with all the annotations and everything. So I would recommend that it would always be better that you download the latest PPT always and delete the previous one. Every time when I will upload the latest PPT, you download the latest one and delete the previous one, because in that way there should not be any confusion, right? So that is basically the point. So please make sure that you are downloading the latest PPT all the time. Okay, so after today's class also I'll be uploading one more PPT. Okay, and you have to make sure that you delete the older one. So students, anything to ask? Any questions you have from the previous class? Any questions if you have from the previous class, you can ask. Just give me 1 minute, let me open the chat box. Yeah. All right. So anything to ask, guys? All right, so let us start. So in the last class, we had started our discussion on climate change, and in the discussion of climate change, the previous topic of our discussion was that we have talked about wet and dry bulb temperature. We have talked about the impact of wet bulb temperature on livestock, on human health, economic impact, and then we have talked about what is greenhouse effect. And then, only up till greenhouse effect we have discussed. I did not tell you the various greenhouse gases. I think that was our last topic of discussion. I am supposed to start from various greenhouse gases, right? You will have to prompt me all the time, okay? Because sometimes what happens, because when I am taking multiple batches, sometimes I miss out what exactly needs to be done, right? Although PPTs are able to help us all the time, but still, if I miss out on any of the points, you would be, please help me out, okay? So in the last class, we have seen how the greenhouse effect happens and what causes the greenhouse effect. We have written that also, that it is the trapping of the infrared rays that causes greenhouse effect, right? All of you can recall, it is the trapping of the infrared light that causes greenhouse effect. Now, the point is, just like how glass functions and traps the outgoing infrared light, just how the glass functions and traps the outgoing infrared light, in the same way there are certain gases which performs exactly in the same way and traps the outgoing infrared light. So if these gases are there in the atmosphere, of the earth, then they will also end up trapping infrared light in the same way how glass traps the infrared light. So imagine if this is the planet Earth, this is the Earth, and this is the atmospheric level. This is the atmosphere of planet Earth. And what all gases do that? So there is one gas which all of you guys know, CO2. CO2 is a very popular greenhouse gas. And what CO2 do? CO2, if its concentration in the atmosphere increases, then CO2 behaves exactly in the same way how glass behaves. So CO2, it behaves exactly in the same way how glass behaves, and it will actually lead to absorption of infrared light. So when the sun's infrared light will enter into the Earth's atmosphere, it will hit the surface and tries to go back. It is this infrared light that is not going to be going out because of high CO2 levels, and this will cause an increase in the global atmospheric temperature. First, the atmospheric temperature increases, and then from atmospheric temperature, the surface temperature increases, hydrospheric temperature increases, ocean temperature increases, and overall we end up creating global warming. I hope all of you get it. So this is typically what is the impact of greenhouse gases, and why it is called greenhouse gases, because they perform the same impact of greenhouse effect but for the entire planet Earth. Now my question to you is, okay, so let's have a look at this particular image from the PMF book itself. So when you look at this particular image, you guys can see, so there is a term used here called radiative forcing. So look at this. So the concept here is that the sun's radiation, you can see 1, 2, 3, 4 is marked here. The sun's radiation travel towards the earth, and ideally it will hit the surface and get reflected back. There are various ways, there are various means through which the sun's light gets reflected back to earth, back to space. Like sometimes the outer atmosphere itself reflects the light back into space, right? Sometimes the outer atmosphere itself reflects the light back into space. Sometimes there are certain clouds which are created in the upper atmosphere, they may reflect the light back into space. But whatever light that enters into the earth's surface, ideally it should be going back into space. A significant part of it should be going back into space. But what happens? The earth also releases heat back towards the space in the form of long wave infrared. Do you guys remember the long wave infrared are basically the low energy infrared? I did not use the word long wavelength yesterday. If you guys can recall, I told you that we haven't studied science yet. So when I'll teach science, I'll use the word wavelength and frequency there. So I just mentioned that long wave is nothing but high energy infrared. So low energy infrared. So long wave infrared is low energy infrared light. So earth, once it will receive, some of the energy of the infrared light is going to be absorbed by the planet Earth, and rest is going to be released. So technically the low energy infrared are going to go back in space. Some of this passes directly through the atmosphere. So some of the infrared light passes directly through the atmosphere, but most of it is captured and retained by greenhouse gases. Most of the infrared light is captured and retained by greenhouse gases, and guys, it is these greenhouse gases which are causing the entire global warming. And now the question is, what is causing all these greenhouse gas emissions? What is really causing this greenhouse gas emission? So when you talk about anthropogenic activities, there are a lot of anthropogenic activities, man-made activities, which are causing an increase in the amount of greenhouse gases in the atmosphere and cause global warming. Now my question to you is, can you give me some examples? Achha, this is not needed here. Can you give me some examples of greenhouse gases? Can you give me some examples of the various gases which are considered to be greenhouse, which have a tendency of trapping the infrared light? Can anyone give me examples? Come on. Very good, Sagar. Hydrofluorocarbon. Very good. Anybody else? We have Bharat and Nisha. So guys, 3 of you guys are attending the class live. I want all of you to keep maintaining this particular discipline. If you have a habit of attending live classes, do turn up every day, okay? Because the only thing that I like in a live class is when students interact, okay? So please make sure that you attend the class on a regular basis. For science, because there are 2 batches for science, so we'll definitely have some good numbers for science students attending live, but I want you guys also to make sure that you are attending the classes live on a daily basis, okay? Remember guys, environment classes will not stop anywhere in between. We'll keep continuing with the environment classes, will not be stopping anywhere in the environment classes. Science classes will take a short break in between because we want some more admission, some more people to watch our videos and then join, okay? But for environment, because the videos are already there, so I'm hoping that students will eventually join environment. They've already have gone through their research and everything, okay? So what all greenhouse gases are there? You have written some examples. Bharat has written methane, Sagar has also written methane, Nisha has written nitrogen. No, interestingly, CO2 is the first greenhouse gas that we all know. Apart from CO2, Another greenhouse gas is methane. That's absolutely correct. But interestingly, Nisha, nitrogen is not a greenhouse gas. Imagine if nitrogen would have been a greenhouse gas, then 78% of the atmosphere is nitrogen. Earth would have been very hot if nitrogen is considered as a greenhouse gas. So nitrogen is not a greenhouse gas. Rather, there is a gas called N2O, nitrous oxide. There is a gas called nitrous oxide, that is a greenhouse gas. So nitrous oxide is a greenhouse gas, not nitrogen. Then apart from that, water vapor and ozone, very good. Ozone is a greenhouse gas. Water vapor is a greenhouse gas, very good. Then there is a gas called SO2, sulfur dioxide. Then there is a gas ammonia, right? All of them are greenhouse gases. Then you have written HFC, hydrofluorocarbon. Then there is a gas called perfluorocarbon, PFC, perfluorocarbon, PER, perfluorocarbon. Right? Very good, Sagar. Then there is a gas called sulfur hexafluoride. Hexa means 6. Sulfur hexafluoride. Then there is another gas called NF3, nitrogen trifluoride. Then there is another gas called CFC, chlorofluorocarbon, and HCFC, hydrochlorofluorocarbon. Chlorofluorocarbon and hydrochlorofluorocarbon, HCFCs. So we have hydrofluorocarbon, HFC, PFC, perfluorocarbon, SF6 sulfur hexafluoride, NF3 nitrogen trifluoride, CFC chlorofluorocarbon, and HCFCs hydrochlorofluorocarbon. All of them are supposed to be considered as greenhouse gases. All of them are greenhouse gases. Okay, all of them are greenhouse gases. But why have I written some of them in white and other in green? The reason is these gases written in green, the gases written in green, they all are naturally occurring greenhouse gases. They are naturally occurring greenhouse gases. All of them are naturally occurring. And when you talk about these white color greenhouse gases, all of these white color greenhouse gases are anthropogenically produced, or you can call it man-made greenhouse gases. Man-made greenhouse gases. These are man-made greenhouse gases. So greenhouse gases are defined, to be man-made and naturally produced. Right? So this is one differentiation between greenhouse gases, man-made and anthropogenic. Now guys, I'll give you one way of thinking here itself. Here itself I'll help you out with one quick way of thinking, because that will help you in addressing lot of things here. Like when you look at the naturally occurring greenhouse gases, when you see these naturally occurring greenhouse gases, these naturally occurring greenhouse gases are basically produced naturally on Earth. So even if humans were not there, even if you do not consider human activities at all, there are a lot of natural reasons through which these gases are produced. Remember that there are a lot of natural ways how these gases are produced. Even if humans are not there in the equation, they will still be produced. Remember that. Okay. So they are naturally occurring greenhouse gases. And guys, what is interesting about naturally occurring greenhouse gases is that nature has its own way. Nature has its own mechanism of absorbing these gases. When you talk about naturally occurring greenhouse gases, nature has its own way of absorbing them. So when I talk about naturally occurring greenhouse gases, one solution that could click in your mind straight away is that naturally occurring greenhouse gases do not require any special intervention. You just have to reduce them. You just reduce the naturally occurring greenhouse gases, nature will find its own way of absorbing them. Like just to give a quick example, CO2 is a greenhouse gas, no doubt about it. And we all know that CO2 being a greenhouse gas, it is a gas which traps infrared. But we also know that CO2 is a naturally occurring gas in the atmosphere. 0.03% of the atmosphere is made up of CO2, and this CO2 is an essential gas for plants to survive. Plants require CO2 in their photosynthesis. So what I'm saying is that if we just reduce the anthropogenic emissions, if we just, anthropogenic emissions means man-made emissions, if we just reduce the anthropogenic emissions of greenhouse gases, if we just reduce the anthropogenic emissions of CO2, nature will itself find a way of absorbing all this CO2 back, right, through photosynthesis. So plant will automatically absorb all this CO2 back in the form of photo or through photosynthesis. So this is the clear advantage when you talk about natural greenhouse gases, right? We only have to reduce them. We don't have to do anything. They can naturally be adjusted. Then guys, when you talk about man-made greenhouse gases, when you talk about man-made greenhouse gases are truly waste. They are truly waste. Guys, I often say this in the class that nature never produces any waste. What is waste for us humans? It may be a resource for some other organism. Like whatever waste we produce, it may become a resource for many microorganisms. It may become a resource for many decomposers. Whatever waste these microorganisms produced, it can become nutrients for new plants. And whatever waste the plants produce, it can become a nutrition source for us. So nature never produces any waste. Nature never produces waste, and this is the clear advantage. Nature never produces waste, and this is a clear advantage that if nature doesn't produce waste, if nature does not produce waste, that means if there is anything that is only man-made in nature, if we have produced these gases, then these gases are really waste gases. Nature has no means of absorbing them. So guys, if we release even one molecule of HFC today, nature has no way of absorbing this HFC. There is no plant, there is no microorganism, there is no substance in nature that is right now capable of absorbing these gases. So when it comes to man-made greenhouse gases, the only solution is complete elimination. The only solution is complete elimination. When you talk about naturally occurring greenhouse gases, the solution is that we only have to reduce the emissions of greenhouse gases. That's the solution. But when you talk about man-made greenhouse gases, the solution is complete elimination. We have to eliminate the release of CO of all these gases completely. That is the only solution we can think of when it comes to greenhouse gases. I believe all of you guys are able to understand. So greenhouse gases, complete elimination for man-made because nature has no way of absorbing them, and for naturally occurring greenhouse gases, the only solution is to reduce. I hope all of you guys are able to understand. So these are all the greenhouse gases. But guys, if UPSC asks a question and they write down these gases and their names and they ask you which of them is a greenhouse gas. So remember, all of them written here, all of them that are written here, they all are greenhouse gases. They all are greenhouse gases. In fact, I would like to give you a rule of thumb. I'll give you a thumb rule also. Look at this. Look at this and answer this question. CO2, N2O, ozone, SO2 and H2O. In all these gases, guys, among all these gases, do you see any common pattern here? Among these 5 gases, do you notice any common pattern? All of them have oxygen. Very good. All of them have got oxygen. That is one common pattern. But apart from oxygen, there is one more common pattern here. Look at them. Look at them carefully. There is one more pattern apart from just oxygen. You know, all these gases are triatomic. All these gases are triatomic. What is triatomic? They all are made up of 3 atoms. They all are made up of 3 atoms. So 1 carbon, 2 oxygen, 3 atoms. 2 nitrogen, 1 oxygen, 3 atoms. 3 oxygen, 1 sulfur, 2 oxygen, 3 atoms. 2 hydrogen, 1 oxygen, 3 atoms. They all are triatomic in nature. They all are triatomic. Got it? They all happens to be triatomic, right? And because they all are triatomic, they are, so the rule is that all triatomic and above, all the gases which are triatomic and above are greenhouse gases. The thumb rule is all the gases in on earth which is made up of 3 atoms or more, they will all be greenhouse gases. They all are going to be greenhouse gases. So remember, all triatomic gases or more, they are always greenhouse gases. They all are greenhouse gases. So guys, there is no need to remember a list. If you can remember the name, like when you look at this NF3, nitrogen trifluoride, there are total 4 atoms. Of course, when there are 4 atoms, 1 nitrogen, 3 fluorine, it will have to be a greenhouse gas because it is more than 3 atoms. SF6, sulfur hexafluoride, 7 atoms, greenhouse gas. HFC, hydrofluorocarbon, that means it has hydrogen, fluorine, carbon, 3 atoms minimum are there. It is a greenhouse gas. PFC, perfluorocarbon, 3 atoms are there, right? Perfluorocarbon is basically methyl group and then fluorine. Then you guys CFCs, chlorofluorocarbon, 3 atoms. Hydrochlorofluorocarbon, 4 atoms. In all possibilities, they all are greenhouse gases. I hope all of you get it. They all are greenhouse gases. I hope all of you get it, right? So this becomes a rule of thumb that if you just look at the name and you'll be able to figure out whether it is a greenhouse gas or not. How easy it is, right? Now the point is, you know, we have written a good list of greenhouse gases, but you know what? All of them are not considered as a major concern in terms of greenhouse gases. Like they all are greenhouse gases. If UPSC asks a question and they mention their names, remember they all are greenhouse gases. They all happen to be greenhouse gases. But it does not mean that all these gases are equally dangerous. There are some greenhouse gases which are, even though they are greenhouse gases, but they are not considered to be a dangerous greenhouse gas. We do not consider them as a matter of concern. And what are those gases which are not considered as a matter of concern? Those gases are, look at water or water vapor. You know, water vapor is a very effective greenhouse gas. It is a greenhouse gas, and that too a very potent one. But interestingly guys, water vapor is not considered as a dangerous greenhouse gas. The reason is because water vapor has a very short life. बहुत छोटी सी life है. Why? See, just think about it. There is some water vapor released. The moment the water vapor is released, we all know, as the water vapor is lighter, it will start rising up. So as the water evaporates, the water vapor rises up, it rises up, it rises up, and as the water vapor starts rising, the temperature of the air starts cooling. As it goes to higher altitude, temperature of the air starts cooling, and a time will come when the temperature will get so cold, it will get so cooler that it will start getting condensed. It will convert from water vapor to liquid droplets and fall back. So what is happening when it comes to water vapor, even if I release a lot of water vapor right now, it will not remain in the atmosphere for a very long period. Hardly for few hours. Hardly for few hours it will remain, and then it will fall back, it will precipitate back. Don't you think those gases will play a much bigger role in greenhouse effect if those gases are having a longer life in the atmosphere? But a gas which is there hardly for few hours, you release those gases, the gas will get condensed and eventually precipitate back. It will start, you know, it will eventually precipitate, and no further, you know, trapping of infrared light will happen because all the water vapor has precipitated. This is the reason that because of its short life, because of its short shelf life, water vapor is not considered as a major greenhouse gas. It is a greenhouse gas, but if UPSC asks you which of them is a greenhouse gas of concern, then water vapor is not. So water vapor, we do not consider it to be a big threat. In the same way, SO2, this gas SO2 also have a short shelf life. SO2 also have got a short shelf life. I'll explain how. Actually, this SO2, when it is released, whenever SO2 is released, what happens to this SO2? SO2 quickly reacts with oxygen and converts into SO3 in the presence of sunlight. In the presence of sunlight, SO2 quickly absorbs one oxygen and converts into SO3, right? Converts into SO3. And guys, this SO3 happens to be a water soluble. It is a water soluble acidic gas. Water soluble acidic gas means that this particular gas SO3 can dissolve in water, it is soluble in water, and it will convert the water into an acid. What is that acid? It is H2SO4. So this SO3, the moment it comes close to water, it converts water into H2SO4. You can see the equation is also balanced. From science background student, I believe they can easily figure it out. It converts SO3 into H2SO4, and this H2SO4 is called sulfuric acid. So basically what is happening, as the water has short shelf life, the same SO2 will also have a shorter shelf life, because all the SO2 that we release will quickly convert into SO3, dissolve in the water and fall back. So technically SO2 and water vapor, they both are not considered to be a major concern greenhouse gases because they are having short shelf life. I hope all of you get it, right? But if UPSC asks you whether they are greenhouse gases, yes, they are greenhouse gases, but we do not consider them as a dangerous greenhouse gas. I hope all of you guys are able to understand. Then guys, next is ammonia. You know what? Ammonia also have the same issue. It also is not considered to be a concerned greenhouse gas because ammonia also breaks down into nitrites and nitrates. There is a process through which ammonia undergoes a process called nitrification. It is a natural process that happens with the help of bacteria. The bacteria that is naturally found in the soil, it breaks down ammonia and converts the ammonia into nitrites and nitrates. And guys, these nitrites and nitrates are eventually going to add soil nutrition. They are going to add into soil nutrition. They will make the soil nutritious. But this is also shows that it is having a short shelf life. So even ammonia is also not treated to be a major concern greenhouse gas because of its short shelf life. I believe all of you guys are able to understand. So we have a lot of greenhouse gases, but every greenhouse gas may not be seen with the same, problem of causing global warming. A lot of these gases have a very short shelf life and they eventually go back, absorb back in some form of the other. So I hope all of you understand that how I have eliminated water vapor, SO2 and ammonia. Got it? I'm deleting these equations here because I believe you guys are able to understand them, right? I would need this space for some more content. Okay. So SO2, water vapor and ammonia. Now guys, we have two more gases which are also not considered to be a concern, a greenhouse gas of concern, and that is CFCs and HCFCs. Why CFCs and HCFCs are not treated as a greenhouse gas of concern? The reason is, guys, what happened? These gases are greenhouse gases. CFCs and HCFCs, they both are greenhouse gases. They are greenhouse gases, no doubt about it. But what happens? These gases, CFCs and HCFCs, these gases have ozone depleting properties. These gases are also called ozone depleting substances. I'll get to a little bit of history here. It may appear to be deviating from the topic, but I'm not. Actually, guys, in 1983, scientists who were studying in Antarctica, I hope you all know Antarctica is a global common. Remember, Antarctica does not belong to any country. Antarctica is governed under a treaty called the Antarctica Treaty of 1958, and under this treaty of 1958, it's called the Antarctica Treaty. Antarctica is a global common, and being a global common, any country can go and set up scientific establishments, observatories, they can perform scientific experiments. Global common means nobody can go and militarize Antarctica. Nobody can go and set up military establishments in Antarctica. Nobody is allowed to set up any kind of weapons in Antarctica, but you can use Antarctica only for the purpose of knowledge, scientific temper. And if you want to work jointly, you can work jointly with other countries as well, right? So Antarctica is governed under the Antarctica Treaty. So in 1983, there was a there were joint experiments between Europe and America, and they were observing the ozone layer. I believe all of you guys know that ozone layer is an important gas. It is found in the stratosphere of the earth. It is found in the stratosphere of the earth, and this gas protects us from ultraviolet C radiation, or you can simply say harmful ultraviolet radiations, right? Harmful ultraviolet radiation. I'll talk about the types of UV light, later on in this section only. We'll talk about it later. So it protects us from the harmful UV light. So we all require the ozone layer. So guys, what happened in 1983? Scientists who were studying in Antarctica, they observed that the ozone layer has started depleting. In 1983, what they discovered is called an ozone hole. They discovered something called an ozone hole. They discovered an ozone hole, and this ozone hole that they discovered, is what they observed. And that's when, the moment that they found that there is a hole in the ozone layer, they raised an alarm at the global level. They raised a global level alarm. Now this global level alarm was raised because, guys, this ozone layer depletion is considered as an extinction level event. You'll be surprised to know that Earth has witnessed, yesterday itself I told you that Earth has witnessed climate changes. In many of these climate changes in the past, volcanic eruptions happened. And some volcanic eruptions were so severe that they destroyed the entire ozone layer. And you'll be surprised to know the ozone layer, when it gets destroyed, the harmful UV light starts entering into the earth in such a way that no living organisms, forget about humans, even bacteria, microorganisms, plants, no living organisms can survive the harmful UV light. So if the ozone starts getting depleted, it is treated as an extinction level event for the entire humanity. The entire humanity may go extinct because of the breakage or holes in the ozone layer. It is treated as an extinction level event. Got it? Ozone depleting. So this is what they discovered in 1983. And guys, the reason that was found, the reason responsible for this ozone hole was not a volcanic eruption this time. The reason was that there were a lot of ozone depleting substances that were being released from anthropogenic activities. A lot of anthropogenic activities were releasing ozone depleting substances. And guys, these substances were the biggest reason behind the ozone depletion. So guys, what happened? United Nations quickly acted. It quickly acted against this particular information, and in 1985, they established what is known as the Vienna Convention. They established the Vienna Convention in 1985. Although guys, it was enforced in 1987. 1987 is the year of enforcement, or you can say adoption. It was signed in 1985, right? Signed in 85, but enforced in 87. right? It is normally the year of enforcement or normally the year of adoption that is to be remembered. Okay, so Vienna Convention was launched, and the objective of Vienna Convention was to protect the ozone layer. To protect the ozone layer. That was the objective of the Vienna Convention, right? To protect the ozone layer. But guys, this ozone layer protection was further, this protection of the ozone layer was actually required. This ozone layer protection was further needed to be very strictly managed. So under the Vienna Convention in 1987, a treaty was signed called Montreal Protocol, right? Montreal Protocol, and this Montreal Protocol was adopted in 1989. 1st January 1989 it was adopted or enforced, and under this Montreal Protocol, ozone depleting substances were banned, right? They were banned globally. And when I say that ozone depleting substances were banned, it means everything about them was banned. You're not supposed to produce them, you're not supposed to use them, and you're not supposed to distribute them. So their production, use and distribution, everything was banned. Ozone depleting substances. All these things were banned. Are you guys able to get it? This is what we have under the simple idea of ozone layer depletion. I hope all of you guys are able to get it. This is what we have under ozone layer depletion. Now guys, my point is, please pay attention, right? Ozone layer depletion. So ozone depleting substances were banned under the Montreal Protocol. So guys, what happened when you look at CFCs and HCFCs? No doubt that CFCs and HCFCs are greenhouse gases. They are greenhouse gases. But remember guys, they were not banned as a greenhouse gas. They were rather banned as an ozone depleting substance. They were banned because of their ozone depleting properties. Tell me yes in the chat if you guys have understood quickly. Are you guys able to understand? They were banned because of their ozone depleting property, not because of their greenhouse gas properties. So CFCs and HCFCs are also not treated as greenhouse gases of concern today because they were banned even before the discussion of climate change was started. Even before the discussion on climate change took center stage, before that itself, CFCs and HCFCs were banned under the Montreal Protocol. Don't worry guys, we'll discuss Montreal Protocol and Vienna Convention in detail. Here I've just introduced you to the concept, but we'll talk about them in detail. Got it? So CFCs and HCFCs, they were banned because of Montreal Protocol even before global warming was even a discussion in the international scenario. Got it? And then guys, if I ask you what was the purpose, why these greenhouse gases were used at the first place? So guys, these CFCs and HCFCs, they were used as refrigerants. They were used as refrigerants in your air conditioners and refrigerators. Like for example, all of you must have observed, I'm very sure that all of you may be having an air conditioner, or you may be knowing somebody having an air conditioner. Because if you come from North India, it has become a necessity in North India today, the kind of extreme heat wave that we face these years. So when you talk about air conditioner, you may be knowing that sometimes before the summer season starts, we normally get our AC serviced, right? Before the summer season starts, we normally get our air conditioners serviced, right? All of you must be knowing this. Sometimes when the AC mechanic comes and he sometimes says that your AC gas has got leaked. You must have observed sometimes the AC mechanic comes up and says that the gas of your air conditioner has got leaked, it needs to be refilled. What is the gas he's talking about? The gas that he's talking about is actually nothing but CFCs, HCFCs or refrigerants. See, these gases are running inside an air conditioner and they basically help in exchanging the heat. So these gases are playing an important role in absorbing the heat of the room and throwing cooler air into the room. So they throw the cooler air and absorb the heat. So if the gas is not there, then there is no heat exchanging medium present. There is no energy exchange medium, and that's why these gases are very important. So where was CFCs and HCFCs used? It was used as refrigerants gases. It was used as refrigerants in the air conditioners and refrigerators. But guys, what happened after the CFCs and HCFCs got banned under the Montreal Protocol? When the CFCs and HCFCs got banned, which gas replaced them? So guys, all these CFCs and HCFCs, they were replaced by HFC. HFC became the replacement of CFCs and HCFCs. So today, if you go and purchase an air conditioner, there is a high chance that you may not get CFCs or HCFCs because it has already been banned. Even India imposed the ban in 2002, in the year 2000 itself. It has been more than 20 years now that these CFCs, HCFCs, they are not produced in India. But if you go look at an air conditioner today, you will find that most of the air conditioners that are being sold in the market, they are having HFC. Now, what is good about HFC? What is good about HFC is that HFC is not an ozone depleting substance. HFC is not an ozone depleting substance. But guys, you'll be surprised to know that it is a highly potent greenhouse gas. It causes extreme level of greenhouse gases. It causes extreme level of trapping of infrared light. Are you guys able to understand? So this is basically what we have under HFCs. So HFC became the replacement of CFCs and HCFCs, and now we are trying to find a replacement for HFC. Guys, just for your additional information, I don't think UPSC will ask this. I don't think UPSC is going to ask any of these questions, but just for your information, I'm sharing with you. See, when it comes to air conditioners, HFC is the most commonly used refrigerant today in the market, right? HFC is the most commonly used refrigerant. But guys, in an actual air conditioner, they will not write HFC. They will write the industrial, code of HFC. So guys, if you ever find R134A written, if you ever find R134A written in any of your air conditioner, your refrigerator, or even in your car AC, remember it is actually HFC. But also do remember guys, HFC is not a single gas. It is not a single gas. It's a combination of 19 gases. There are 19 different types of gases. Actually, HFC is nothing but hydrofluorocarbon. This hydrofluorocarbon can have multiple possible arrangements. With hydrogen, fluorine and carbon, it could be having multiple possible arrangements, and all of them have different names when it comes to HFC. Like there is one gas called DFM. DFM is called difluoromethane. Difluoromethane. Its industrial name is R410A. R410A. DFM. R410A, and this R410A is actually a gas within the family of HFC. So if you purchase an air conditioner recently, do check which is the refrigerant. If it says R134A, avoid it. If it says R410A, avoid it again. And even if it says R440A, even this also should be avoided. All these refrigerants has to be avoided because they all are nothing but types of HFC only. It is just for your own information, guys. I don't think UPSC will ask the industrial names of these greenhouse gases, right? Just for your information. But now the question is, if you should avoid all these greenhouse gases, then which one you should purchase? Which greenhouse gas you should ideally purchase? So guys, the ones that you should purchase, we have some better alternatives. These alternatives are also greenhouse gases, but they are somewhat better because their shelf life is smaller, shorter, so they are comparatively better. Like we have R32. we have R290A, we have R600A. These are some good examples of gases which can be good alternatives. Like guys, R600A is cyclopentane. If you do not know what is it, don't worry about it. R290A is isopropane. It is not required to know what is the meaning of isomer and all those things. R32 is ammonia. Right? All these are better alternatives compared to HFC. So today if you go and purchase an air conditioner, R32A, R32, not 32A, R32, R290A, R600A, all of them are good choices. I hope all of you guys are able to understand. Got it? I hope all of you understood. Please write down yes in the chat. It was just for your own consumer behavior, right? Just to make you an informed consumer, this information was important. I hope all of you get it, right? Please tell me yes in the chat if you guys have understood. So this is what we have. So these are the greenhouse gases of concern. So CFCs, HCFCs are eliminated. Now guys, when you talk about NF3, even this NF3 is also eliminated, guys. We don't consider NF3 also as a dangerous greenhouse gas right now. Although it is a dangerous greenhouse gas, but the reason why it is not considered is because NF3 is released in semiconductor manufacturing. In the manufacturing of semiconductors, NF3 is produced, right? NF3 is produced in the manufacturing of semiconductors, nitrogen trifluoride. And guys, you all know, you all understand that how important it is for us to produce semiconductors today. Semiconductors are considered as one of the most important materials in all high-end computing, in all advanced devices. So in order to make semiconductors possible, we have to somehow accept the release of NF3. So right now countries are not putting a concern on NF3 because semiconductors is playing an important role. So right now we don't consider it as a dangerous greenhouse gas, but it is actually a greenhouse gas which is quite dangerous, right? NF3. I hope all of you understand. So NF3 is also not treated as a greenhouse gas of concern, right? Although it is produced in semiconductor industry. I hope all of you guys are able to understand. Now I'll quickly discuss all the greenhouse gases that we are left with. So guys, let us write down the names of the greenhouse gases that we are left with. So guys, we have CO2, methane, N2O, HFC, PFC and SF6. All these 6 greenhouse gases are the ones that we are going to discuss, right? We are going to discuss these 6 greenhouse gases one after the other. But before that, let us look at this image. So here is the image of something called natural versus human-induced greenhouse gases. Now guys, this is natural greenhouse effect. The greenhouse effect that is caused due to natural greenhouse gases. Guys, I hope you understand that the naturally occurring greenhouse gases, they were there even when humans were not there. Like CO2 was being released even during the time of dinosaurs. CO2 was there, ozone was there. So these naturally occurring greenhouse gases were always there on Earth. And I hope you understand that these naturally occurring greenhouse gases, they would have been responsible for maintaining the warmer, or I should say ambient temperature of the Earth. The most ambient temperature of the Earth, the most optimal temperature of the Earth was being maintained not because of only the current greenhouse gases, but they were there because of naturally occurring greenhouse gases. So guys, we cannot say that we do not need greenhouse gases at all. We need greenhouse gases, but only to an extent when they are helping the planet Earth to remain warm in a healthy manner, right? If their proportion increases so much that they start trapping more infrared, which causes problems to us of global warming, then it becomes a concern. So greenhouse gases is not a concern until their proportion increases, especially not natural greenhouse gases. So natural greenhouse gases, they are considered a problem today, but it was never a problem before in the Industrial Revolution, because these gases were playing a role in keeping the Earth warmer. See, without the greenhouse gases, Earth would have been extremely cold, because then there would have been no trapping of infrared light, and Earth would have been nothing but an ice ball, right? A ball of ice. So naturally occurring greenhouse gases are the ones like NO2, CH4, and CO2, water vapor, that they will allow the sunlight to enter, and some of this light will go out, and a very little, only some of this light is going to be trapped, which will maintain the right temperature of the Earth's atmosphere for living organisms, for ice caps. Everything can easily sustain, right? The heat that escapes out is more than the heat that gets reflected back into the Earth. It is the case with naturally occurring greenhouse gases. But when you talk about human induced greenhouse gases or human enhanced greenhouse gases, like the CO2 emissions today are very high, methane emissions today are very high, N2O emissions today are even higher, nitrous oxide. Because of these gases which are having high emissions today, Earth is still receiving the same solar radiation, we are still receiving the same sunlight, but now majority of this light, you guys can see, majority of this light is going to be trapped back into the Earth, and a smaller light, less heat escapes into the space, and more heat gets redirected back into the Earth, and that is causing the problem of global warming. I believe all of you guys can understand. So this is the issue of global warming when you compare the two situations here. Got it, all of you? This is the problem of global warming. Now guys, let's talk about the various sources of these gases. Let's talk about the sources. Now guys, for majorly for these sources of the greenhouse gases, I would recommend that you guys refer the PMF book, right? The PMF environment book. You have to refer to the PMF book for these sources, right? You have to refer to the book, because the book has given all possible sources. It does not mean that I'm not discussing. I will discuss, but I would still expect you guys to refer to the PMF book. Original book you have to read, because the coverage that they would provide is much better than what I would provide. Okay, right? I hope all of you get it. Acha, which chapter? Acha, oh, I'm so sorry guys. I haven't told you which chapter we are studying. Just wait. I'll tell you the chapter. I think it is chapter number 9, but let me just still check. So the chapter that we are referring is, it is, I should have told you which chapter we are starting technically. No, it is not chapter number 9. It is chapter number, then I think it is 17 if I'm not wrong. Yeah, chapter number 18. What we have started is chapter number 18, right? Chapter number 18, 19, chapter 18, chapter 19, chapter 20, and guys, chapter number 21. Chapter number 22. So chapter number 18, 19, 20, 21, 22, all these. So chapter number 18, 19, 20, 21, 22. These 5 chapters we are going to finish in our discussion of climate change only. In the first PPT itself, we'll finish these 5 chapters. Please do mark chapter number 18. I'm referring to the 3rd edition of the PMF environment book, which is the latest edition. You have to read chapter 18 to chapter 22, right? It is always better if you can read ahead of me, right? Because I'll take almost 7 to 8 class to finish this topic. If you guys can go ahead of the class, it is even better, because then you can ask more and more questions, right? All right. So please refer to the book. It is from chapter 18 to chapter 22, right? Chapter 18 to chapter 22. These are the chapters we are covering. Okay. All right. So coming back to this, what are the various sources of these gases? CO2, CH4, N2O and such. So guys, when I talk about sources of CO2, I often tell this in the class, I often say this in the class, that all developmental activities all development activities are typically the sources of CO2 emissions. What do I mean by saying that all developmental activities are CO2 emission sources? I'll explain this. But before this, let me quickly talk about some natural sources. First, let me talk about natural sources, guys. So please tell me, all of you, do you guys understand the meaning of the word biomass? Or I should write down biomass here. We have some empty slides here. Right? Tell me, guys, do you understand the meaning of the word biomass? Biomass. What is biomass? Very good, Sagar. Very good. Biomass is simply known as weight of an organism. Weight of an organism minus weight of water. Weight of an organism minus weight of water. What does this means? Suppose if my weight is 100 kg, guys. Let's suppose if my weight is 100 kg. Let's imagine that if I am 100 kg of weight. We all know nearly 70% of the human body is water. I believe all of you guys are aware that nearly 70%, nearly 70% of the human body weight is water. Nearly 70% is water. So if nearly 70% of the human body is water, that means if I take the total weight of an organism, that is 100, and subtract 70%, that is 70, the weight that will be left is 30 kgs. So guys, this 30 kg will be my biomass. So biomass can be also called as total dry weight of an organism. It can also be called as total dry weight of an organism. How the dry weight? I hope you get it. It is basically the weight of an organism minus the weight of water, right? Total dry weight of an organism is called, biomass. Now guys, let's imagine that there is some biomass. Let's imagine that there is some biomass that is lying on the ground. Let's suppose this is the ground level. I want you guys to answer very quickly, okay? And let's suppose this is some piece of biomass. Now guys, this biomass could be a dead animal, a dead plant, or nothing but animal waste, human waste, anything. All these things are biomass, okay? Now typically what is biomass made up of? Guys, biomass is typically made up of carbon, hydrogen, oxygen, nitrogen, sulfur. These are basically the elements that will have all this carbon, all this biomass made up of. Yes, carbon is an important ingredient. So carbon, hydrogen, oxygen, nitrogen, sulfur, all of them are those elements that constitutes biomass. Got it? Now guys, what happens? Because this is lying above the ground, there is enough supply of oxygen. Oxygen is available, and we all know biomass is something that is biodegradable. So on the ground, it will also have bacteria, fungi, and slime molds. Remember guys, what are these organisms? These are decomposers. These are decomposers. Remember, bacteria, fungi, and slime molds, these are the three organisms that are considered as decomposers. Remember, viruses do not decompose. Virus is not a decomposer, right? So bacteria, fungi, slime molds, these are the decomposing microorganisms. So bacteria, fungi, slime molds are decomposers. So what will happen? The bacteria, fungi, and slime molds will start attacking this biomass. And as they start attacking this biomass, what will happen? The carbon part will break and release in the form of CO2, right? Carbon would break and then release in the form of CO2. Hydrogen, oxygen would also break and release in the form of water, right? Hydrogen, oxygen would get released in the form of water. Nitrogen will also break and release in the form of first nitrite, and then further oxidation produces nitrate, nitrite and nitrate, right? ATE. whenever you have the suffix ate, whenever you have ate suffix, you understand the last part of the word is called suffix. Prefix is the first part of the word, right? Word. So last part of the word is called suffix. So whenever you have words like ate, like nitrate, sulfate, citrate, phosphate, right, and so on, whenever you have these suffix ate, it means that it contains oxygen. It means that it contains oxygen, and that too, that is saturated. In fact, I should rewrite it. It basically means that the element are having saturated level of oxygen. The elements have saturated level of oxygen. Or guys, you simply say that it contains oxygen, right? Don't talk about saturated levels. Saturated level means that it cannot hold any more oxygen than this, right? So you just remember that when it contains oxygen, we use the word ate, right? We use the suffix ate. So whenever you have the word sulfate, phosphate, citrate, nitrate, it means that there is oxygen alongside with those elements. So with nitrogen there is oxygen, with sulfur there is oxygen, with citrate is basically, it comes from citric acid, hydrogen and carbon, it has oxygen, and phosphate, again with phosphorus there is oxygen. That's it. Sulfur will get released in the form of SO2. Guys, all these products that are formed, can you see something common in these products? Tell me, can you see all these things that are common in these products? Can you find anything common among these products that are produced in the breaking of this biomass? Carbon in the form of CO2? Yes. Oxygen. All these products that are created in the breaking down of biomass, they all contain oxygen. So guys, what do you call this type of decomposition? What do you call this type of decomposition which happens in the presence of oxygen? We call this form of decomposition as aerobic. This is called aerobic. Aerobic decomposition. This is called aerobic. It is happening in the presence of air. Aero means air. Aerobic, right? Aeroplane, a plane that flies in the air, right? Aero means air. Got it? Aerobic. I believe all of you guys are able to understand. This is called aerobic decomposition. It is happening in the presence of oxygen or air. Understood all of you? Aerobic. Now guys, let's imagine there is some other biomass. Let's say there is some other biomass of the same type, of the same nature, but this time it is buried under the ground. It is buried under the ground. It is not on the surface, it is inside the ground. Now this is a situation where oxygen supply is not there. There is no oxygen. But guys, even under the ground also, we have bacteria, we have fungi, we have slime molds. These organisms are still there. So now it is still made up of the same substances: carbon, hydrogen, oxygen, nitrogen, sulfur, right? Carbon, hydrogen, oxygen, nitrogen, sulfur. Now when this biomass will start breaking down, bacteria will still attack this biomass and would break down this biomass. Fungi, bacteria, they all will attack. But because this kind of breakdown is happening in the absence of air, this type of breakdown is happening in the absence of air, how far this is going to be different. So what will happen? The carbon now, it will again break, but this will not produce CO2 because oxygen supply is not there. Rather, it will produce methane. Hydrogen and oxygen, they both will still produce water. they both will still produce water, H2O. Nitrogen this time will not produce nitrates. It will produce, because there is no oxygen, it will produce ammonia, NH3. And sulfur will not produce SO2, but it will produce H2S, hydrogen sulfide. It will produce hydrogen sulfide. So when you look at these chemicals that are formed, can you notice that there is no oxygen? Of course, water is having oxygen because some oxygen is there in the biomass, but otherwise there is no oxygen here. There is no oxygen. And what does that mean? When there is no oxygen in this biomass, what do you call this type of decomposition that happens in the absence of air? Tell me guys, what do you call this kind of decomposition that happens in the absence of air? We call it anaerobic. That was called aerobic. This one is going to be called anaerobic decomposition. This is called anaerobic decomposition. It is happening in the absence of air. So guys, what I'm trying to tell you here is that if you talk about CO2 as well as methane, they both are naturally occurring gases. They both are naturally occurring gases. And guys, did you notice that both these methane and CO2 are produced from the same source? They are produced from the same source also, biomass. But the only difference is methane is produced when the biomass degrades in the absence of air, and carbon dioxide is produced when the biomass degrades in the presence of air. Are you able to understand? So I can easily say that when you talk about CO2, I can say that CO2 is produced by aerobic decomposition of biomass. Aerobic decomposition of biomass. All of you would agree to this, right? And I can, in the same area, I can even talk about methane, and I can simply say methane is produced by anaerobic decomposition of biomass. Guys, you understood this part? Please write down yes in the chat. Anaerobic decomposition of biomass. So where there is aerobic decomposition, it is CO2, and wherever there is anaerobic decomposition of the same biomass, the source is the same. For both methane and CO2, the source is the same. In both the sources, it is biomass. Acha guys, one more thing. I should tell you one more thing here. When you talk about anaerobic decomposition, remember guys, anaerobic decomposition happens in absence of oxygen, sunlight, right? Because sunlight can also cause photodegradation. So in the absence of oxygen, in absence of sunlight, and guys, this type of decomposition is rather a slow process. It is a slow process, guys, right? And temperature and humidity, they play important role, right? If the temperature is high, humidity is high, and oxygen is also high, this condition induces faster decomposition, right? So guys, you can understand why anaerobic is slow, whereas aerobic is a faster decomposition because it is happening in the presence of sunlight, or in the presence of oxygen. And if the sunlight is also there, then it will also have the right temperature and it will happen much faster. Right, remember that. I hope all of you get it. So anaerobic is a slow process and aerobic is a fast process. I hope all of you guys are able to understand this part. Now guys, let's come back to this point. So we have CO2, CH4. Both of them are produced from the same source. Both of them are produced from biomass. So there is no difference in terms of the sources of methane and CO2. They both have the same sources. But now guys, going back to this. So CO2 is produced wherever there is anaerobic decomposition of biomass, right? So it is produced naturally from all these sources, right? It is produced naturally from all these sources naturally, right? It is produced like this. Then guys, we can also say natural respiration of organisms. Guys, I hope all of you would agree to this also. We inhale oxygen and exhale CO2. So CO2 is being released in natural respiration as well. Respiration also releases a lot of CO2. All of you would agree to that also, right? So respiration can happen both in animals and plants. Both animals and plants undergo respiration. Remember that, guys. All plants undergo respiration. Just like all plants undergo photosynthesis, all plants undergo respiration as well. Right? Sabhi plants mein hota hai. It happens in all the plants. Right? CO2 emissions. Animals and plants. Both animals and plants releases CO2. Then guys, natural CO2 will also be released whenever there is forest fire. Right? Carbon burns in the presence of oxygen. Fire requires oxygen. It will release CO2. Wherever there is, forest fire, agriculture, stubble burning. Have you heard of this issue, guys? One of the major issues for poor air quality in North India is agriculture stubble burning, but it is a seasonal issue, right? Other issues are vehicular emissions and those, but seasonally, agriculture stubble burning is one of the major issues. So when you talk about CO2 emissions, forest fire, agriculture stubble burning, all of them are one of the constituents. Yes, Haryana, Punjab, although guys stubble burning happens across North Indian states, but Punjab reports the highest number of stubble burning cases, right? So all of them are going to produce CO2. But interestingly guys, you will find that all of them also produce methane. They are also natural sources of methane emissions. But we'll talk about methane later on, right? So all of you guys have understood this part. So these are the major sources of CO2. But these are all natural sources of CO2 emissions. So guys, I don't have to tell you separately that these are specific sources. Now, my point is, why did I write all developmental activity releases CO2? Why did I write that? So guys, when I talk about developmental activities, we all understand the fact that almost all developmental activities that we have, they all are directly dependent on some type of carbon-based fuel. Almost all developmental activities that we have, they are dependent on some kind of carbon-based fuel, right? Almost all developmental activities is dependent on carbon based fuel. Guys, let me ask you a question here, and I want all three of you to answer. This. If I ask you, what is the meaning of the word development for you? If I ask you, what is development for you? If I say that, define development, what do you understand by this particular word? What is development for you guys? Tell me. Construction, very good. Infrastructure, good infrastructure is development. Good quality construction is development, right? Modern transportation is development. Transformation, I think, Bharat, what you mean by transformation is basically transforming into higher standard of living. I think that you will say as development, right? Higher per capita income, better nutrition, better livelihood, better, life expectancy, healthier lifestyles, better education, cleaner environment. I believe all of you would say this. All these things are definition of development. I hope, Nisha, you will also agree to this. All these are the meaning of the word development. All of you would agree? Now, the point is, what makes development a reality? So guys, if I want to have a high standard of living means that I have access to the resources. What access of resources? I have a good all-weather house. I have internet. I have access to good nutritious food. I have access to health services. I have access to telecom services. I have access to entertainment and recreational services. There should be amusement parks, all these things. Guys, just think about it. Is there any of the activities that can happen without emission of carbon? If you talk about construction of houses, roads, flyovers, expressways, all of them are made from cement. All of them are made from cement. Just to give you a quick example, guys, you know what is cement? Cement is actually made from lime. Cement is made from lime. And what is lime, guys? Lime is calcium oxide. We also call it quick lime. One and the same thing, right? Quick lime and lime is one and the same thing, right? Quick lime is basically when it dissolves in water, it's called quick lime, right? Calcium oxide. But you know what? Calcium oxide is highly reactive, guys. It is highly reactive. It is not found naturally. So how do we produce calcium oxide? We produce this calcium oxide with the help of calcium carbonate. So we have calcium carbonate. This is called limestone. Limestone is made up of calcium carbonate, and this limestone is heated. It is heated. And guys, it is not heated to 100, 200 degrees Celsius. It is supposed to be heated to 1500, 2000, 3000 degrees Celsius. And for heating the limestone, we require coal. Coal is needed to heat the limestone. Sometime charcoal, sometime coke. So guys, coal is often used to heat the limestone. And once the limestone is heated to a very high temperature, this releases, or this breaks down into lime and CO2. The equation is also balanced, guys. Lime and CO2. So what is happening, whenever the limestone breaks, calcium carbonate breaks, it releases CO2. CO2 gets released. And guys, when you burn coal, when we burn coal, coal is also nothing but a carbon-based fuel. Carbon-based fuel means coal, petrol, diesel, kerosene, all of them are carbon-based fuels. Natural gas, or what you call methane itself, methane is natural gas, right? All of them are carbon-based fuel. So you name the fuel around you, it will have some carbon, right? It will have carbon. So coal will also release methane, CO2 emissions. So don't you think all the construction that is happening in the country, it is all happening at the cost of very high CO2 emissions? And guys, it's not just this. When you talk about access to resources, it also comes with transportation. Transportation means, again, all the transportations, they are made in factories. Factories are running on electricity, energy that is powered from coal. You'll be surprised to know that nearly 70% of all electricity production in India is coming from just coal, guys. So if India ends up producing more energy, more electricity, don't you think it will simply release more CO2? Even if I talk about electric vehicles definitely are non-polluting vehicles. They do not emit any pollution. But guys, in the process of making electric vehicles, factories are running on energy which is produced 70% from coal. They are emitting a lot of CO2. The battery manufacturing, batteries are made from lithium ion. Now guys, lithium ion batteries are supposed to be highly dangerous when it comes to environmental impact, because lithium ion batteries are supposed to be, they are causing a lot of emissions. A lot of emissions gets released from lithium ion batteries, and one of the major problem of those emissions are, because in the mining, because the process of mining lithium, a lot of trapped methane and CO2 gets released into the air. A lot of CO2 and methane gets trapped in the topsoil and it gets released into the air in the process of mining itself, right? So when you talk about EVs also, EVs may not be the point source of emissions. They may not be emitting CO2, but the charging of EVs is emitting CO2, and the manufacturing of EVs is emitting CO2. Are you guys able to understand? So any developmental activity that comes to your mind, it will release CO2. It will produce CO2. I hope all of you guys are able to get it. This is what is the meaning when I say that all developmental activity causes CO2 emissions. You name the developmental activity, it will release CO2. Whether it is iron ore manufacturing. Now iron manufacturing, again, iron is not extracted in the form of iron. It is extracted in the form of an ore called iron ore or hematite. The hematite has to actually be put in a blast furnace, which also has a temperature of 3000 degrees Celsius, burnt through coal. Are you guys able to understand? So now you know what, because we know that all these manufacturing produces CO2. So now there is a new type of steel being introduced in the country. It's called green steel. Green steel is a type of steel which is made from iron ore only, but instead of making a blast furnace of coal, they make blast furnace of electricity. They make an electric furnace, and the electric furnace is normally powered through solar cells. Are you guys able to understand? Tell me yes in the chat if it is making sense to you. Come on guys, quickly tell me yes in the chat. Just give me 1 minute. I'll be back in a moment. All right. So I hope all of you understood. All right, perfect. So when I talk about all developmental activities, it releases CO2. So guys, there is a new sentiment emerging. There is a new sentiment that is emerging, and this new sentiment says that we have to eliminate CO2 emissions from development. Right? Is it possible for us to achieve developmental standards? Whatever you wrote about development, is it possible for us to achieve all this without emissions of CO2? We have to somewhat, actually guys, there is a term that I should introduce here. The term is called decoupling. The term is called decoupling. Right? I'll write this term here. The term is called decoupling, guys. What is decoupling? Decoupling actually means we have to decouple CO2 emissions and development. Like guys, it was something that was believed 20-30 years back that any country which is emitting more CO2, it means it is consuming more resources, it is consuming more fuel, it is developing faster because it is releasing more CO2. But guys, in the 21st century, we have a new definition for development. That can we keep developing? Can we keep increasing the development standards? Can we keep increasing the per capita income? Can we keep increasing the standard of living without causing CO2 emissions? So can we keep achieving high development standards by reducing the CO2 emissions at the same time? So earlier, CO2 by development and CO2 emissions, they were coupled with each other. Earlier, development and CO2 emissions, they both were coupled. If you are developing, you are causing CO2 emissions at the same time. That was the belief earlier. But now, the CO2 emissions, the development and CO2 emissions, it is believed to be counterproductive. If development is happening, CO2 should start decreasing. And that is the meaning of the word decoupling. So one important strategy that we will be using, this term decoupling, you should keep using in your answers. So we have to find a way to decouple. We have to find a way to decouple development and CO2 emissions. Today, almost all developmental activities releases CO2. But if we can find a way of decoupling CO2 emissions and development, then that would be the right definition for development, or that should be the right definition for future development, right? So guys, this is what is the meaning of the word decoupling. We have to decouple both the things. So development should not mean high CO2 emissions. We have to decouple. Got it, all of you? So there are new trends coming up under decoupling initiatives. There are new trends coming up, that is green steel. That means it is normal steel, but instead of using coal-based blast furnace, they use electric furnaces. There is green cement. Green cement is normal cement, but instead of using coal, they use electric furnaces to break down limestone. And whatever carbon that is released in breaking down the limestone, we are capturing that carbon back into the earth. We are doing equal number of plantation, which can capture the carbon again. So all these are new trends which are catching up in development activities, which are trying to define the word decoupling. I hope all of you guys are able to get it. This is what we have under development activities. So guys, I'm not elaborating from here. I'm leaving the discussion here only on CO2, because when you study the PMF book, you will have so many other sources. You guys just need to write those sources in your notebook, right? I'm not adding anything from here. I'll just go to the second greenhouse gas, which I feel is very important, and UPSC have a newfound interest in asking questions on the second greenhouse gas, which is methane, right? So let's talk about the major source of methane emissions, right? Let's talk about methane emission sources, right? I'll do one thing, I'll write down methane emission sources here. So guys, again, methane is also a natural occurring greenhouse gas. So natural sources of methane would likely be same, right? Here we will simply say anaerobic decomposition, natural sources. To define natural sources, anaerobic decomposition, wherever it is happening, it will produce methane. Guys, don't you think natural sources mein wetlands produce methane naturally? You may ask, guys, what is a wetland? You may ask, what is a wetland? So guys, a wetland, as the name suggests, wetland is basically a land which is wet, right? Land which is wet, wetland. So guys, we normally define wetlands are places where soil hydration, wetlands are places where soil hydration is more than soil aeration. Do you guys understand the meaning of this term? Soil hydration. See, don't worry about remembering wetlands. We will discuss wetland ecosystem in the second chapter. When we discuss ecosystem degradation, that will be the second PPT. We'll talk about wetlands and I'll discuss everything about wetland ecosystems there. Okay. So it will not be a problem to any one of you. Okay. Wetlands. So when I talk about wetlands, wetlands are those ecosystems which are having high soil hydration than soil aeration. Do you guys understand the meaning of this term? See, soil hydration basically means it has high amount of water. It has more water in the soil than air, right? More water in the soil than air. Let me just quickly talk about what is the meaning of more soil hydration than air. So imagine if this is a layer of soil. Suppose this is your topsoil, right? Your topsoil. Now guys, normally the soil is porous. It has pores. The soil in general has got pores, guys. It is porous. right? Soil in general is porous, right? It has got pores, and in these pores air is trapped, right? Air is trapped generally soils is porous, and in these pores the air is trapped, right? But guys, in case of a wetland, all this air, all these pores, they get filled with water. There is water in all these pores. The pores are filled with water. So if there are pores filled with water, if all these pores are filled with water, that means there is less oxygen, and if there is any biomass that will undergo degradation, that will undergo decomposition, it will not have enough oxygen, and because it will not have enough oxygen, this biomass is going to release methane. Tell me yes in the chat if you guys are able to understand. Tell me yes in the chat if you guys are able to get it. It will release methane, right? So methane emissions happens from wetlands. So wetlands naturally produces methane. Then guys, not just wetlands, guys, volcanic eruptions. See, volcanic eruptions, when I'm writing for methane, they are also common for CO2 as well, because methane and CO2 dono same source hai. Both of them are coming from the same source, right? Volcanic eruptions will also have, right? All these are natural sources of methane emissions. Got it? Now when you talk about anthropogenic sources, the first source is mining. All mining activities releases methane. How? I hope you get it. What do we do in mining? We cut, we drill into the soil, we unearth. So as we are drilling into the soil, we are breaking down rocks. Any kind of mining, whether it is mining of rocks, whether it is mining for minerals, anything, it is going to break down the soil, break down the rocks, and there would be high chance of methane being trapped inside coal, inside rocks, inside soil, and thus methane is going to get released, right? Methane, mining. Then guys, apart from mining, can I say methane can also be emitted from something called legacy waste sites. What is a legacy waste site? Guys, all of you must have seen this image from Delhi. It's an image from Delhi only. You guys may be knowing that our urban cities, if you have never been to Delhi, good for you, right? Our urban cities, they have been facing a huge crisis of poor waste management. I hope you all know that in the name of waste management, the Article 73rd and 74th, the 73rd and 74th Amendment to the Constitution, they have empowered municipalities in India. They have empowered municipal corporations. And you guys know one of the important function of municipalities and municipal corporation is waste management. One of the important function is waste management. So you know what happens? These organizations, when they perform waste management, one of the important criteria is to basically dispose the waste. But guys, many cities in India, in fact all the cities, in fact barring few cities, they face this problem that they do not have infrastructure to manage the waste. So they simply acquire a land outside the city or the outskirts of the city and start dumping waste there, thinking that slowly and slowly we will accumulate or develop technology and we'll try to reclaim this land. Now guys, look at these sites. These sites are called legacy waste site. You know why legacy waste site? Because these sites have been accumulating waste generations after generation. In the first year, this site might have been up till here, but next year the site got even more waste, then some more waste, then some more waste, some more waste. Like this, layers by layers, the entire waste site keeps getting keeps getting higher and higher, and now it has taken shape of a proper mountain. You know, Delhi has got 3 such legacy waste sites on almost. Delhi is sharing its border from with UP and Haryana. So 2 sides Haryana, 1 side UP. All the openings of Delhi, they all are having these waste sites. Right? So these are legacy waste sites, and just imagine these legacy waste sites, if you try to observe the kind of gases that would be emitted. See, these legacy waste sites will have all types of waste. It will have both biomass and non-biodegradable waste like plastic and all, right? It will have both biomass and non-biodegradable waste. The biomass that is on the surface, it will release CO2 because it will have oxygen or access to oxygen. But what about the biomass that is inside, which is of higher quantity? The biomass that is inside, this will be releasing methane. Tell me yes in the chat if you are able to understand. So guys, legacy waste site will produce both CO2 and methane, but more methane. The legacy waste site. Tell me yes in the chat if you guys are able to get it. So these are also important locations of methane emissions, right? So legacy waste sites. Then guys, one of the biggest constituents of methane emissions are, of course guys, you can also write down fossil fuels, especially natural gas. Natural gas, this also emits methane, natural gas. And guys, apart from legacy waste site, fossil and mining exercise, one of the major constituents are dairy and agriculture. Dairy and agriculture are 2 very massive contributors of methane. Guys, let me talk about dairy first, right? Then we'll talk about agriculture. So you'll be surprised to know, United Nations FAO stands for Food and Agriculture Organization. United Nations FAO, Food and Agriculture Organization, in 2023 declared or published that 41% of all methane emissions comes from dairy, which constitutes 33%. Second is paddy. Paddy is rice cultivation, right? Paddy or rice, which constitutes 8%. And guys, 20% comes from legacy waste sites. 20% comes from legacy waste site. So if I talk about anthropogenic, this is a report on anthropogenic methane emissions. If I talk about anthropogenic methane emissions, a majority of them comes from dairy, rice cultivation and legacy waste site. You understand how legacy waste site you have understood because of anaerobic decomposition? Don't you think paddy, you can also understand paddy as the same concept of wetlands. Paddy fields also, you guys know that when it comes to rice cultivation, there is a method of rice cultivation that we use traditionally. Traditional rice cultivation, if I just show you the image of rice farming, all of you must have seen probably, right? So if I just write down rice cultivation, yeah. If I just search rice cultivation and look at the images, all of you must have seen this is the common site. This is the common site that we see when it comes to rice farming. What this lady is doing, this lady is planting rice saplings. She's planting saplings of rice in a field that is flooded with water. Guys, can you see the entire field is flooded with water? Rice is a kharif crop. Today in science we have talked about it. So she's planting saplings of rice on a field which is completely flooded with water, which is completely flooded with water. So when you see this, it gets clear that rice is actually acting like a wetland. Look at this, the same image, right? All the states that are producing rice, look at them, they are planting saplings of rice, right? So these saplings are transplanted. This may be an image from Vietnam or some other country, right? So this is a common site. Don't you think they will be behaving like a wetland only? So paddy also produces methane because all the soil gets completely hydrated. Any kind of decomposition of biomass will release methane, right? Of course, some CO2 may also be released, but mostly it is methane. Tell me yes in the chat if you guys are agreeing to this, right? So rice also produces methane, right? Now let's talk about dairy. So paddy, legacy waste, all of you can accept. Let's talk about dairy and how dairy is a contributor. So guys, if I talk about dairy sector primarily, you know, in India, the dairy sector is, I will not say very developed, but dairy sector is very important. You guys know that India is the largest producer of milk in the world. We are the largest producer of milk, right? Why? Because we have the highest population of livestock in the world. दुनिया में सबसे ज़्यादा livestock इंडिया में है, right? Now, guys, the animals that are cow-like animals, they are called bovines, right? Bovine basically means cow-like animals, right? Cow-like animals. And guys, these bovines are also known as ruminant cattle. Cow is also called as ruminant cattle. So bovines or cows, they are called ruminant cattle. The question is, what is the meaning of the word ruminant, right? So guys, when you talk about the human digestive system, when you talk about our digestive system, see, our digestive system, we have got a stomach, and our stomach is a single chamber. Even if you have not studied biology, but you guys know that our stomach is a single chamber. हमारा जो पेट है वो एक single chamber है. The food goes into the stomach and goes out of the stomach in a single chamber. But if you ever look at the stomach of a cow or a bovine, if you ever look at the stomach of a bovine, you'll notice that a bovine's stomach is actually having 4 different chambers. It has got a chambered stomach. The first chamber is called a rumen. The first chamber of the cow is called a rumen. A rumen is the first chamber of the cow. First chamber of the cow's stomach is called rumen. Now guys, what is there in this rumen? See, remember, this is stomach, guys. This is stomach, not lungs. Guys, have you ever fed any food to a cow? I'm pretty sure all of you must have fed some food to a cow. Have you noticed that whenever you feed a roti to a cow, let's suppose, or you can feed other things also, when you feed anything to a cow never takes bite. What she does, she swallows the entire food. A cow swallows the entire food. She doesn't take bite, she swallows the entire food, right? She swallows the entire food, right? And the food goes directly into her stomach. But where exactly in the stomach? It goes directly into the rumen. The food goes into the rumen, right? So whenever you feed any food to the cow, the food goes into the rumen directly. And guys, what does the rumen have? A rumen have methanogenic bacteria. It has methanogenic bacteria. It has got bacteria naturally which are methano. So guys, genic means generate. Genic means generate, and methano means methane. So they are methane generating bacteria. These are bacteria that are naturally found in the rumen of the cow. Naturally found bacteria in the rumen of the cow, methanogenic. Now these methanogenic bacteria, there are a lot of examples of methanogenic bacteria. Like we have examples like we call it methanospirillum, Methanospirillum, Methanobacter, Methanococcus. These are all methanogenic bacteria. They produce methane, right? So these are all examples of methanogenic bacteria. These bacteria are naturally found in the rumen of the cow. And what happens when these bacteria start attacking the food? They release methane. And guys, once the food gets broken down, it gets partially digested in the rumen. This partially digested food, it's called cud. This is called cud, right? So partially digested food is called cud. And what the cow eats, you must have observed that when you feed something to a cow, the cow swallows the food, but she is still found to be chewing something. The cow always appears to be chewing something. वो कुछ ना कुछ चबा रही होती है. You know, actually what she is doing, the food goes into the rumen breaks down the food into cud, and then this cud, the cow pushes the cud back into the mouth and she chews the cud. We call this activity as belching of cows, right? We also call these bovine as curd chewing animals. Remember, it's called cud, not curd. So this cud is then going to be pushed out, and along with this cud, methane also goes out. So in the process of cud chewing, cow releases a lot of methane. And guys, let me tell you, this methane release is very important. If the methane does not go out of the cow's stomach starts swelling. It starts expanding. It can cause bloating to such an extent that it can be life-threatening to a cow. So a cow has to release this methane, which is produced in abundant quantity, guys. बहुत quantity में produce होता है. So now you can understand why these ruminant cattle or cow-like animals can have high methane emissions, because of this process of belching or cud chewing, right? Now India has got the highest population of livestock in the world. So you can understand that our dairy industry is one of the major constituents of methane emissions. Dairy industries are one of the major constituents of methane emissions. Are you guys able to understand? So India being one of the highest population of livestock, and our dairy industry has the highest methane emissions. I believe all of you guys are able to get it. Please write down yes in the chat if you have understood. Please write down yes in the chat if you guys have understood. So this is the problem of methane emissions from dairy, right? So you'll be surprised to know that out of all the greenhouse gas emissions that takes place, 33% comes only from dairy. 33% comes from dairy. So you can understand the problem here, right? So every time when we are getting all the milk that we need, it is coming from a lot of emissions of methane. But guys, let me tell you a harsh reality of the dairy industry here. Guys, I hope, I'll talk about that thing later because we don't have that much of time. So this is what is the issue of dairy and methane emissions. But guys, I think it is better that if I talk about methane controlling here itself. So guys, FAO in 2023 published in one of the reports stating that dairy farming is causing so much of emissions. But guys, at the same time, FAO has given some solutions as well. Like guys, when it comes to legacy waste, the only solution is to eliminate. We have to eliminate, right? We have to start land reclamation, right? The only solution of legacy waste site is land reclamation. We have to reclaim the land reclamation, and that is the only way how we can reduce the methane emissions from legacy waste site. When it comes to the methane emissions of rice, there is something called direct sowing of rice, or DSR, direct sowing of rice. I'll show it to you. DSR machines, these are seeding machines, right? There are a lot of different types of DSR machines nowadays. So if I just write down DSR rice, you will see direct sowing of rice. Look at this. This is the direct rice seeder. You guys can see tractor operated mild steel DSR, direct seeding rice, right? What is this particular machine? Look at this. This is where the person is using DSR. So here what he's doing, he's not putting saplings of rice. They're not putting saplings of rice. They are actually putting seeds of rice. So the saplings need not be put because saplings require standing water. A lot of water that emits CO2 as methane. But direct seeding of rice will not require water that much. Basically what the farmers are doing, they are putting seeds of rice, and around the seeds of rice, with the help of this seeding machine, with the help of these seeding machines, they are producing little grooves. Can you guys see the edges of the seeding machine here? So see, it is rice grain planter of the company National. So these are grooves that are going to be created. They are going to create small channels, and around the channels they will sow the seeds. So farmers, they will not have to flood the entire field. They only have to put water in the channels, right? So they will make those channels, and through those channels you guys can see the rice plantation is happening here without any water stagnation. You can see this. It is a photograph of Punjab. No water is standing here. Don't you think when there is no stagnant water, there will be less methane emissions, and we are also able to grow rice easily? So one solution for avoiding the methane emissions of rice is direct seeding of rice. Look at this. See, this is how it works. This is a very good image of direct seeding of rice. You can see these kind of grooves that are made. These grooves will only require, so you only have to put water in the grooves, and rest of the field remains completely unflooded. So guys, direct seeding of rice can reduce the water requirement by up to 80% and can eliminate methane emissions by up to I think again 80% only. It can reduce methane emissions by 80% and can also reduce water requirement by up to 80%, right? This is the advantage of direct seeding of rice. I hope all of you understand this, right? So this is what we have under DSR. So guys, the method that is used traditionally is called TPR. TPR is called transplantation of rice. Transplantation of rice, and DSR is direct seeding of rice. So we have been able to notice that DSR and TPR, they produce same quality of rice. There is no change in the quality of rice here. I hope all of you guys are able to get it. This is how they have been able to solve the problem of rice, right? And methane from rice. But guys, when it comes to and guys, for land reclamation also, I'll talk about land reclamation better when we discuss waste management. Now guys, what about dairy? What kind of solutions that we can think of for dairy sector? So here there are 4 solutions. There are 4 solutions when it comes to dairy sector. And guys, I'm going to talk about these 4 solutions tomorrow. Why tomorrow? Because today we will not be able to complete. And in the same discussion, I will also talk about all the mechanisms that we have adopted in reducing methane emissions. Okay. So here itself, I'll talk about the initiatives on methane emissions as well. Got it, all of you? Tell me yes in the chat if you guys have understood everything in today's class. Actually, the reason why I'm leaving you a little early, actually, last night, unfortunately, my daughter was not doing well. She's just 1 year old, and she was not able to sleep. So me and my wife, we had a very tough time, right, in putting her to sleep. So unfortunately, I was not in a position, but I didn't want to cancel the class. So I thought of continuing with the class. But tomorrow, when I'm going to meet, consider that I may extend the class by up to 10-15 minutes, right? Every day, guys, the class may get extended by 10-15 minutes. Please be prepared for that much of extension. Okay. So guys, this is everything in today's class. I'll be meeting you guys tomorrow. If you have anything to ask, please ask. Remember guys, environment classes will not be called off in between. We'll have environmental classes. All 30 classes will go on continuously. Of course, Sunday would be an off. Right? I'll use Sunday for making answer writing notes and such, right? So I hope all of you guys are able to get it. This is everything in today's class. Tomorrow when we meet, we'll start from this particular part. Okay. All the best, guys. Thank you.